Honors Algebra 2 Pre-Calc, we're doing section 2.7, which is part of our chapter 6/partial fractions unit in Pre-Calc. Example 9, write the partial fraction decomposition for the quantity x minus 2 over the quantity x squared minus x minus 6. So this problem is actually fairly straightforward and easier than some of the other recent examples. Like, I'd argue this is easier than 8 or 7. But what's tricky is that when we get to the final answer, I want to address something that comes up sometimes when we run into fractions. So the first thing I'm going to do, as always, is fully factor this side, and I'm going to factor it into an x minus 3 and an x plus 2, right? So my setup is going to be an a over an x minus 3 plus a b over an x plus 2, right? Because I have two linear factors that are completely distinct, all I really have to do is multiply each fraction by the other fraction's denominator, essentially. So this guy's missing the x plus 2 over the x plus 2, and this fraction is missing the x minus 3 over the x minus 3. So when I look at the numerators only, I'm going to get, so if I look at numerators only, I'm going to get x minus 2 equals an a times the quantity x plus 2 plus a b times the quantity x minus 3. And I'm going to be able to use clever substitution pretty easily because it's easy enough to pick a number that'll make x plus 2 be 0. So if I pick x equals negative 2, I get a negative 4 equals a bunch of 0 plus b times a negative 5. So I'm going to end up getting 4/5 is my b. And right there, that's the reason I picked this problem, because I want to talk about what happens when we get fractional answers for our constants. I'm going to do the same thing to find a, right? I'm going to pick a number that conveniently knocks out x minus 3. So over here, I'm going to pick x equals 3. And I'm going to get 1 equals a times 5 plus a bunch of 0. So I'm going to get 1/5 as my a, and that's fine. So objectively speaking, this problem's been much easier, but what's hard about this problem is that when you write your answer, you're going to have fractions in your fractions, and that feels awkward. So when you write your answer, you're going to get a, which is 1/5, over an x minus 3, plus b, which was 4/5, over an x plus 2. Now, that's not completely wrong, but it's unconventional to leave it that way. It's also not great to change these into decimals. Like, you shouldn't make this a 0.2 and this a 0.8. The best way that you can do this is to put the denominators on the bottom. So you can make this a 1 over a 5 times the quantity x minus 3 plus a 4 over, on the bottom, a 5 times an x plus 2. Now, what I will say, so in pre-calc, I really want the answer that either looks like this guy, or I'm sorry, that looks like this guy with the 5s on the bottom. Or if you want, you could distribute the 5s on the bottom, and you could make this a 5x minus 15 on the bottom, and you could make this a 5x plus 10 on the bottom, right? So in pre-calc, I would prefer one of these two sets of answers, right? But what's interesting is this is by far the most useful of the answers for AP Calc. So when you're actually integrating these expressions, right, when you're anti-differentiating, which is a thing that in pre-calc you have no idea what I'm saying, so I'll just say that right now, you don't know what I'm talking about. This is going to be the most useful form that you're going to see in pre-calc, or in calc. But in pre-calc, we usually want you to simplify and put that 5 on the bottom, either like this, where it's in front of parentheses, or where you distribute and make it a 5x minus 15 and a 5x plus 10. Again, just wanted to throw out there, sometimes you do get fractional constants, and it's not a big deal. It happens.